Yeah, I'm Dr.Natakorn Phuksuksakul. Now I'm a lecturer at Department of Civil Engineering, Thammasat School of Engineering. So let's see I'm going to talk today. So the first one, I try to bring in, this is a wrong slide because I put the wrong paper here, but the context is about the driver simulator, using it to study about the driver behavior and how the mobile phone used while driving is affect to driving performance. I will try to wrap this thing up. So for this study, uh, we try to we try to simulate the city environment to study how the mobile phone using while driving behavior affects the driver performance. So in this study, you measure the following distance, the speed, perception reaction times, steering angle, steering wheel position. We measure everything across different situations. The first one is the base case, which is normal driving. Just look at the screen and drive. And then the next one is about calling while driving. So the participant if you are a participant, you have to talk to the phone. Actually, they talk to me like some normal conversation and see how they interact with the environmental around. And then the last one is about typing some message while driving or searching some information on the internet. So across, in the simulator situation, this scenario, you have to write something to answer. For example, I send you guys some message and then you type something back while you are driving. And yes, we compare all the performance in overall across different age group. We have young driver, mid-age or I would say mid-age driver, which is 40 to 50, and then elderly driver, which is 60 and over. We have 100 participants in total. And even though it doesn't affect much, these types of behavior, mobile phone use while driving, it doesn't affect much to the young driver, but it significantly affect mid-age driver and elderly driver. For example, the variation in speed is quite higher, which means you try to drive with different speed. Sometimes you go faster, sometimes you go slower, and also the following distance is also varied by different speed as well. And then what we also found is that the perception reaction time is also increase. So it means if you see something on the road while you are using mobile phone while driving, then you interact it like slower compared to the normal situation. And on top of this study, rather than just try to study on the driving simulator, rather than try to study on driving performance, we try to study the driver perspectives. We split we split our questionnaire survey to about 500 driver and also 500 motorcyclists across Bangkok and some other part of Thailand. I think we have a major city in the east, the north, and south. So for province, only the major city. We try to study how they think why about the using mobile phone while driving behavior. We use theory of planned behavior, extended a little bit with risk perception, as you may see on the right bottom figures. We add risk perception and we also add law enforcement to the typical theory of planned behavior model. And we try to see what is happening. We found some interesting result from this part, which saying that even though Thai driver and Thai motorcyclists, they know and they totally realize how much they have to pay if they got caught, if they got arrested by using mobile phone while driving, but still they would like to use it. So these types of thing, I think perhaps we need a stronger law enforcement or some equipment that can cause this behavior on the road. So yeah, this is overall of this study. And then the next one is about This one first, I would say that it is about the injury severity of the active traveler. As you may know, in urban mobility, they try to promote active traveler. As you can see, we have lots of bicycle lane. We have lots of better or improving in pedestrian sidewalk. Uh, and yeah, we all know this too. We call it active traveler, right? Bicyclist and pedestrian. So they are the most vulnerable road user on our road network, as if they got crashed by vehicles. So it would like to be a direct impact, and it is likely to be more severe. So in this study, we try to study the factor that likely to influence active traveler injury severities. But as you may see, the profile of the injury severity profile of bicyclists and pedestrian, they are somewhat different. Yeah, this might be happen because of the impacts of the vehicles. For example, if you are pedestrian, you got crashed by a vehicle, so you're likely to get a direct impact rather than a secondary impact like bicyclists. So that is why for bicyclists, you might got a higher chance to get moderate injury compared to pedestrian. But on top of this one, if we consider only injury severity, we might lose some perspective about effects of crash. So that is why we try to see the correlation between crash risks between these two of road user, and also try to see whether it is correlated with their injury severities. Yep. So in this study, we use a copula-based, a binary logic generalized order logic model. So the binary logic is for the crash risks, whether they are pedestrian or they are bicyclists. And the generalized order logic model, here we split the two of them, as we assume that the injury severity profile between the two road users are different. So now we have three types of model to be tested and try to see whether they are correlated or not. And on top of everything, we try to solve the unobserved effects problem, unobserved heterogeneity across different injury. Across different pedestrian and bicyclists. And let's see the result of this study. So after we got the result, yeah, they are correlated somehow, and also we got the probability plots between bicyclists and pedestrian injury severity outcome across different year. So for this study, I forgot to mention that we only use the data from the year 2012 to 2018. And we have four types of injury severity, which is a minor injury, moderate injury, major injury, and fatal injury. If you look at these two figures, you may see on the left top that they are not much different. But on the right side, as you can see, the moderate injury and major injury, the trend between the two is likely to be the same.
Progress.
On fatal injury, as you can see, pedestrian may likely to be more serious, especially in 2018. And I guess if we update the model to 2009, if with the new crash data, we might see the trend longer that it is going to increase or decrease to reflect what is the good countermeasure or things that is not effective to improve this active traveler safety. All right, and after we have done with our model, we try to see the elasticity effect, whether which factors related to active traveler injury severity is likely to contribute toward the fatal injury outcome or minor injury outcome. In overall, as you can see, the lower posted speed limit, if the crash happened in the lower posted speed limit, they are more likely to get minor injury. But on the other hand, if pedestrian got caused by, if they are drunk and they walk and then the vehicle crash, they're likely to be more severe. So they're likely to get to be involved in fatal injury outcome. Same to bicyclists, alcohol and bicyclists, and alcohol and motorists, and also the effects of lower speed limit also benefit to both of them. So now we can see that the lower process speed limit 10 to 30 kilometer per hour, 40 to 50 kilometer per hour process speed limit zone is a friendly process speed limit for active traveler. And that is why in this study, we try to see whether what if we can reduce the process speed limit to, like the higher process speed limit to the lower one. And yep, for this study, as we discussed, as I presented to you before that, process speed limit is quite important. And in the absence of in-crash data, I would say that we don't have the real crash speed. So we try to use process speed limit to stand for the absence of these variables. And as you can see from this figure that, for example, for this figure, if active traveler crash with vehicles on 50 kilometer per hour process speed limit zone, they have about 20% chance to survive. But if the speed increase I'm sorry, yeah, if higher than 50, they have only 20% for the chance to survive. But if this crash happened at 30 or 40 kilometer per hour process speed limit zone, the chance to survive is higher. All right. So we can see that as we can see now, if we can reduce the process speed limit, the chance to survive is likely to be higher. In that case, so one of the major advocacy to improve active traveler safety is to lower process speed limit. Yep. And so this study, we also assume that some behavior of active traveler, yeah, we know that the chance to survive is higher, but some behavior of the active traveler might be different across different process speed limit. In higher process speed limit, for example, 100 kilometer per hour process speed limit or 90 or 80, people might not be able to cross the road, and also perhaps they react different compared to this lower process speed limit. So in this study, we propose to develop a latent segmentation based active traveler injury severity model. And also we allow for this homogeneity assumption to allow for the difference between active traveler behavior. This is the crash data that we use, the figure on the right-hand side. This study we use active traveler crash data from Queensland, Australia from the year 2015 through 2020. And you can see that there are likely to be somewhat different injury severity outcome across the year and also across process speed limit. Yep. All right, this is the structure of the latent segmentation based model. So on top of everything, we have latent segmentation based model to split between active traveler behavior, which one is likely to be in each segment. And after that, we simultaneously use the generalized order logic model again to see whether the factor that influence injury severity component. For our result, this one, we can split active traveler into two groups, the lower severity segment and high severity segment. And the factor that likely to classify these two groups, we have at-fault active traveler, we have crossing carriageway and also rural area. So after we see this parameter, we try to give a name to these two segments. So we call the first segment here as road rule compliant active traveler, those active traveler who try to follow the rule. And then road rule non-compliant active traveler, the one who did not follow the rules. And then after we split to these two, we see the overall elasticity effects of them again. So again, here, as you can see, highest process speed limit and drunk active traveler, they are significantly increase the chance to get fatal injuries when crash with vehicles. And again, for minor injury, 10 to 30, 40 kilometer and 50 kilometer per hour process speed limit roadway also friendly, also have some benefits on active traveler injury severity outcome when crashed with motor vehicles. All right. After that, on top of this one, we try to make something to show about our policy analysis. And here we plot a probability surface plot through different situation. So we have base situation where active traveler crash on lower process speed limit roadway in urban areas until the higher risk situation. The highest one is higher active traveler crash on high process speed limit in rural area, and they also at fault when they got crashed and also perform crossing carriage way action. You can see from this surface plot that in the first scenario, the probabilities of minor injury is quite high, and then it dropped it dropped by the increasing scenario, which is the higher risk situation, the higher risk scenario. Yep. And on the right hand side, we would like to see if we decrease a speed limit. For example, if we decrease the speed limit from 40 kilometers per hour to 10 to 30, from 50 kilometers per hour to 40 kilometers per hour, what it is going to be like. And we can see that in overall, if we decrease the process speed limit, they give some benefits to active traveler. And perhaps you might see the red color on the right side, which is if we shift 50 kilometers per hour to 40 kilometers per hour, there are not much effects. So this might be because of 50 and 40 kilometers per hour. There are some places that are a kind of like a variation in different vehicles style and zone. For example, in Australia, in 50 kilometers per hour, we have built-up zone and we have commercial zone where there are lots of vehicles involved in this area. But in 40 kilometers per hour, it's likely to be residential area. So the difference between the two might cause this result. Yep. And overall, in this study, what we highlight is that there are heterogeneity in active traveler across different process speed limit location. As you can see, different the factor that we use to classify active traveler group in latest segmentation-based model. We also found a correlation between segmentation and injury severity component. We have several advantages of lower speed limit on roadway, and yet the riskier situation regarding process speed limit and some risk area, also the higher injury severity outcome. And also we show the overall benefits of a reduction in process speed limit. That is all of this study and all of the presentation. Thank you.